Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This week's episode is brought to you by the Austin Building Enclosure Council. And here to tell you a little bit more about a great event they have coming up is their founder, Keith Simon. Keith, tell us what you got.
Thanks, Miguel. We have a really exciting event coming up here in Austin on October 18th. It's going to be a full-day symposium called X Enclosures at the Lime, which is the former Radisson Hotel right on the water. And we have our keynote speaker is going to be Lauren Ricketts from RDH. He is a fantastic speaker. He's going to be talking about continuous insulation and cladding attachments. And I've seen this presentation before. It is, I was on the edge of my seat for the whole time. He goes through all their research and all the different clips and fiberglass attachments and metal attachments and quantifies how much energy loss and the performance of each of them. For those of you who are really into enclosures and high-performance wall systems, our whole lineup for the whole day will keep you on the edge of your seat. So
you heard it here first. If you're in Austin and you want to check this event out, we'll put a link in the show notes for this episode. Now sit back, relax, and enjoy the rest of the episode.
Welcome to this.
Welcome to the
Building Science Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to architecture and design.
Brought to you by Positive Energy in Austin, Texas.
Okay, hello and welcome back, everybody. Welcome back to the Building Science Podcast. I'm Kristof, here as always with Miguel.
Hey, guys.
And I'm also here with my good friend Keith Simon, who's been on the episode before, and we are also here. We have the honor of being with Duane Jonlin from the city of Seattle. Duane, please elaborate on your role and tell us how you ended up there.
I'm the Energy Code and Energy Conservation Advisor for the building department, and I was a practicing architect for 30 years, and my predecessor, after an equally long time, left this position, and I managed to waltz into it. I think they hired me, in fact, because I'd never worked for the government before. My role is basically to write each successive edition of the Seattle Energy Code and cheerlead and teach and move it forward. And I have a similar role with the state of Washington, guiding that committee forward to develop codes as far and fast as we can in a cost-effective way.
That's such an important role for society, and we will talk about that.
And I'm here, this is Keith. I'm here because I attended the ASTM symposium on air leakage in San Diego earlier this year, and I saw Duane speak there. And Duane's talk about what he's done with the city of Seattle and air leakage requirements was just really inspiring, and I just kept thinking the whole time, man, we've got to do those things here in Austin too. Mm-hmm. And so I that's why I wanted to connect Duane with Kristof and Miguel and all of you listening on the podcast.
Thank you so much for doing that. So what about the jump between practicing architect and your role now? Was it just a direct transition? They said, oh, we do this.
People are in with plans, and I have to resist the urge to pull out my red pen and start telling them how they should really do a wall section. But I have to say that's not my role anymore.
Interesting.
It is actually a highly creative thing that I get to do now, maybe more so than when I was a practicing architect.
And I noticed you didn't call yourself the Energy Code Czar, and I think that would be a more appropriate time.
People actually do refer to me as the Energy Code Czar,
right,
and they probably have other less polite ways to describe me as well.
So my question is, I'm going to call you the Czar. How did you move from practicing architect to Energy Code Czar?
So I was asked to apply for this position. I was asked a couple times, and finally I did, and I was accepted, perhaps largely based on the fact that I wasn't a government employee up to that point, and I would have sympathy for the construction crews and design teams and everybody else who's trying to make this real. I think too many people in the code development space are not deeply enough into the actual practice of getting things built to understand all the implications of it.
Mm-hmm. That's really important. And so who asked you? You don't have to name names, but
Well,
what type of person?
Actually, it was there was somebody who called me up on the last day that this position was open and said, "Duane, is it going to kill you to just apply?" And he was like one of the sustainability directors for Seattle. But and then 2 weeks after I started, he left for New York, but left me holding the bag. It is actually a highly creative position because we, like Austin, like New York, like California, are going out and trying to make new things that have never existed before, to come up with some kind of a policy that could apply to every imaginable building that you're going to build in the next several years and to make it effective. It's difficult to conceptualize to begin with, and difficult to pin it down with just the right words that it could work for a grade school or a skating park or anything else you might build.
That's awesome. And listeners to this podcast will know we have said many times about what's between us and just fantastic buildings, multiple interlocking dimensions of beauty, right? Health, sustainability, durability, energy use. Is much more societal, cultural, relational, social, psychological than it is technical. So when you say creative, those are the dimensions, as well as it has to be crunchy and...
No, it's absolutely true. Everything starts out as a technical discussion, but it rapidly becomes political and personal. Mm-hmm. And there's just no way around that. And that's not just energy, it's everything to do with buildings, because it's all wrapped up in tradition, and buildings are incredibly expensive, and everybody is as nervous as cats, about these huge investments they're about to make, and people pretty much don't like being told what to do, which means that being the code guy is not usually a popular position to be in.
So that might be a good segue for you, Keith, to...
Yeah, how about I give an overview of air leakage, whole building air leakage testing, the metrics that are out there to lead into, so that Duane can talk about what he's done with Seattle.
And the lead-in is people don't like being told what to do.
Right. So the code requirement for new non-residential commercial buildings is 0.4 CFM, that's cubic feet per minute, that's a volume of air, per square footage of enclosure area, so per square footage of walls and roof and floor, tested at a certain pressure, 75 pascals. So that 0.4 is a metric for the code minimum, which is really, really, really easy to meet. The problem is it's not a requirement for non-residential buildings to test for whole building air leakage, and so people just don't know what the air leakage rate of their buildings are. The reason why that's important is because air tightness of buildings is critical for energy performance, and it's kind of, I'd say, one of the last low-hanging fruits, because we've sort of maximized the right amounts of insulation levels, mechanical systems. Certainly there's ways to go in all pieces of it, but air leakage is mission critical, and we're just, as a country, not that good at it yet. So if 0.4 is the code requirement, then the U.S. Army Corps of Engineers came up with their own standard, and they developed 0.25 as their goal standard that they go for, felt that after a lot of testing and research that is a reasonable metric. And then the Canadian standard is tighter than that. I believe it's 0.1 or 0.15. And then the tightest metric out there is the Passive House Institute US, which is at 75 pascals, it's 0.08. which is something like 4 times tighter than the U.S. Army Corps of Engineers standard. So Passive House is sort of looking at ultimately what is the most energy efficient way to do a building, and it's a really, really airtight building. Mm-hmm. Of course, a lot of people will jump to the conclusion, isn't that bad for indoor air quality? Well, you have to ventilate correctly, and you have controlled ventilation. You actually have, usually on these high performance such as Passive House buildings, you have better indoor air quality because of the controlled ventilation rate.
By the way, it is not a good thing. People say buildings need to breathe for some reason, but having wind leaking around your window frames is not a smart way to do it, because actually stuff is condensing in there and it's growing little microbial stuff that is then coming into your building. So it's actually rather unhealthy to have your air supply being leaked through your walls.
Buildings don't need to breathe; they need to dry out.
Yeah, the
metabolisms need to breathe.
This to get started was one of the less popular things that we do, but I think it's one of the biggest bang for the buck things. It is not. Once you learn how to do it, it's not that much different to build a tight building than to build one that's leaky. And because you're using all the same materials, everybody's just paying more attention to those interfaces. But the energy savings are huge, because it looks like, since we have introduced this requirement, that leakage rates are about half what they were before. And that means that there's that much less outside air coming in that has to be conditioned to be comfortable and replaced. That is, if you tried to do that same amount of efficiency by using higher efficiency mechanical equipment, that'd be really expensive. Mm-hmm. But just sealing things up, it's no big deal. The trick is that leaks in the building don't occur through the face of the wall, or what they do is they occur through the interfaces between where one trade's work stops and the other one starts. Mm-hmm. And nobody's really responsible for that little transition in between, and leaks happen, or the penetrations through the wall, to put conduits through, or pipes or whatever, are usually badly sealed. Once you have the requirement in place and you start doing this, then you got the general contractor riding herd on everybody saying, no, you can't do that anymore. We set the code requirement up in an unusual way, just to make this politically palatable to get started. We said, okay, you have to do the test, you have to report the results, you don't have to pass.
There is no threshold.
There's a threshold, and if you don't pass, you have to do a few more extra things, but you can still get your occupancy permit. That was because people were petrified about, because, as Keith just said, they don't actually know how leaky their buildings are, that they would be on the day before move-in trying to get this test finished and realize that they're failing. So we said, okay, you can still move in. What has happened is that now contractors are using this as sales material for going to their potential customers and clients and saying, look, we got our leakage down to 0.3, 0.2. That shows what better quality of work that we're doing. And so they've actually turned it to their advantage, and owners are starting to get savvy about this. There's one university system near us that is requiring really tight buildings from all their people, and they do require that as part of their contract. So it's got it into the vocabulary of what people do.
Mm-hmm. So I want to reiterate that, because it's almost earth-shattering that the whole building air leakage test is required, but there's essentially no penalty if you don't meet the code requirement, the 0.4 requirement. Is that right?
That's right.
That's awesome.
And so what's crazy about that is, intuitively you think, well, then it must not make a difference. But what you're saying is you've seen quantifiable results that, it still makes a big difference.
It's in everybody's awareness now, whereas it didn't used to be, and everybody starts to realize who it is that's making these leaks. And sometimes they were huge leaks that no one, there's the point where a roof system meets the top of a wall is notorious there for leakage. The place where the big mechanical mechanical vents penetrate, is all these things that now they're doing really well. Nobody was really thinking about it or being aware of it. There's a favorite quote I have from Mark Frankel at the New Buildings Institute. His quote is, "That which exists must be possible." So, Keith was just talking about a leakage rate, maximum leakage for passive house that's like 20% of what we allow. So it means that somebody's doing buildings that are at that level of tightness, and they're doing them over and over, and they're making it pass. So my intention is to introduce to Seattle this coming code cycle that, yeah, you got to pass. Mm-hmm. And that'll be the next thing.
How many years have you been with the growing awareness or the pump priming phase? Or
I think that has been in our codes for 8 years now. Mm-hmm. So the first couple times out of the gate for everybody were challenging, to put it politely, and there were often crews in there all night, like running around trying to figure out why things weren't working, and eventually somebody would realize there was a big escutcheon plate that just hadn't been put in, or there were thresholds missing, or something like that was messing it up. So little by little they've been figuring this out. So now, instead of I actually interviewed a number of them, and their number of hours invested has dropped dramatically. The technology they use for the testing equipment has improved, and everybody's knowledge about how they have to do this has improved, and the coordination between the testers and the general contractors has improved.
Yeah, it's clear that what's happening is you've managed to shift the culture of your industry, which is profound.
You hit the right word, because all these things with the changes we're demanding in building construction are culture shifts, and that makes it really difficult. It's somewhat easier in a city like Seattle because we have. We're actually blessed with an array of general contractors, testing firms, engineers who are top notch, and do terrific work, so they can handle it best. Then, as a culture shift, this starts to get to the smaller contractors, and then starts to move out to the smaller towns and more rural areas. I think with these culture shifts in building construction, which is very resistant to change, right? Everyone wants to just be able to do it like they did the last building. That it might take a full decade from the time that a place like Seattle or Austin or New York starts doing something until it's way out to the furthest reaches of the state.
Or even longer. And it's interesting, a few things. This quote comes up. It's someone that I like. Someone once said, "What does he know of London? He who only London knows." And so, what does he know of Central Texas building techniques? If that's all you know, what does he know? But getting back to, and I noticed a huge difference. So we work projects in Seattle, and here I am in Austin, which is no slouch, for energy code and for quality. And I work residential, very kind of high-end projects. Go to Seattle and just am so impressed with the buy-in from the architects. The general contractors are incredibly knowledgeable, and that's where I want to go. So you've achieved buy-in from the GCs. You've even achieved peacocking around air control layers, air control measurements from the trades. And I don't know how that just happens. You just described it, and that's my question now, as you were blessed with these trades, as though the angels sang and delivered to you some GCs. But you attracted them, or you grew them? How did that happen?
Seattle has a pretty good culture of quality all around, and people up there would be surprised to hear me saying all these nice things about them, because mostly I'm only giving them grief when they fall short of the mark. But I've heard that many times. Oh yeah, that's easy for you to do in Seattle, but out here we've got the contractors we've got and like that. But still, all these people know each other, and they get together for meetings, and staff moves from firm to firm, and so that's the way these things can disseminate from the top-notch general contractors and consultants out to the people who are doing simple design build office parks or something like that.
Yeah,
just takes a while. You got to be patient.
It took 8 years, but more than that, really.
Yeah, it takes more than that. We also actually in Washington State have for a longer period of time, over a decade, required air barrier testing for houses, and in that case you do have to pass. And our Washington State University has done this tremendous outreach program over all these years.
Yeah. They're
very well respected, and the local contractors have learned how to do this and learned how to do tighter buildings, and they also are out bragging about how theirs are better than the guys down the street. People want to do good work, and people want to be admired for what they're doing. So like we said at the beginning, this tends to be more about personalities and passions, than about reason. Well, you can piggyback on that.
Yeah, I just wanted to clarify 1 second for your listeners about whole building air leakage testing, because probably a lot of them are familiar with blower door testing, where you put a fan in the door of, say, a single family residential house, and you pressurize it and measure its air leakage. And whole building air leakage testing of commercial or larger buildings is the exact same idea. It's just way scaled up and gets more complicated in order to do so. So on, say, a 50,000 square foot office building, maybe you need 12 fans instead of 1 fan, and you have to spend all day long prepping and sealing and figuring everything out. So it's a much bigger endeavor, but it's still kind of the same idea. So, Duane, are there any limits to what you've tested, or what are some of the largest projects out in Seattle that have been tested?
We have tested skyscrapers, and actually we've come up with a routine for that, because once you get more than about 18 stories or so tall, it's very hard to pressurize the whole building equally like they need for these tests. So we've come up with a routine where they are able to isolate floors. Usually you have the floor above above and below where you're testing can be pressurized so that you're not losing air in that direction.
So guarded.
Because we're trying to just check it out. So they would test the ground floors, which are full of loading docks and entry doors and all these kind of things. But then for the tower part, for every 10 stories that we go up, I say they call me when there's 10 stories ready to test, and I pick 2 adjacent floors. So they've got floors 12 through 21 ready to go. I say, okay, 17 and 18. And then...
Always 17 and 18.
Nope.
I'm just joking.
Yeah, and so they then do whatever final prep work it is, and they test those 2 floors, and I say, okay, if those pass, then the whole stack passes. It's turning out to be less of an issue with
the
those
whole
buildings. That whole stack of 10.
12 and 20,
yeah.
Got it.
And because actually curtain wall systems are very beautifully engineered things that fit together perfectly every time. It's kind of a miracle. They're just really precise. And so we don't have any problem with the curtain wall portion of it. And yeah, then we have them do another test for the top floors, and they're done. And that way they only have to kick people out of one reasonably small area at a time. It's difficult scheduling for these people because usually somebody's in there practically 24/7 on a rush project. There's always an electrician or a painter or somebody, and so to close down a whole building site and say all you guys go home for the next 8 hours or whatever while we test is tough. This way, with a bigger building, we do it chunk by chunk.
Mm-hmm.
A similar thing has to apply for a couple other situations. One is multifamily buildings that have the entrances from outdoor balconies,
right,
instead of an indoor corridor. You can't pressurize the whole thing, and you obviously don't have 52 separate fans to do all the 52 units, right? So I have a routine for testing a certain number of those, and also for multi-tenant retail that has its own entrances and stuff. And those go at different schedules, so you have to be able to test one chunk at a time.
So the test is required. There's no significant penalty to not meeting code, but you also have incentives for meeting the U.S. Army Corps of Engineers standard of 0.25. Is that right?
Well, the code in Washington State requires that you pick 2 above code things out of a list of 8 things to do, in addition to everything else. And one of the possibilities is to test to a tighter standard. And yes, depending on the building type, 0.25 is typically it. And so people who have been building the same kind of building repeatedly and have confidence, they know they always beat it by a mile, those people can go ahead and use that as one of their above code notions. The trick is, though, if you choose that, you got to pass, because we have that's considered an additional thing.
Interesting.
I should say also that this last code cycle, Seattle chose to go from the 0.40 standard down to 0.30. I had suggested that we go to that Corps of Engineers standard at 0.25, but I can remember all the testing agency people in the room and the general contractors looking at each other and going, no, that's a little too scary. We're not ready for 0.25. And then somebody said, well, 0.3, that would work, and they all started nodding. I think because they've gotten that experience, they know that 0.3 is achievable, and that most of their projects were already hitting that anyhow.
Yeah, it's important.
So are you there in the building on site when these tests are going on?
No, it's actually an interesting point. Once they seal everything up and turn on the fans, nobody goes in or out the whole length of the test, and that could be a long time. And so I've been in watching them prep for these tests. But otherwise, I get the test results, afterwards, and
So you asked for a video or a picture, or it was just
the testing agency.
It's third party.
Says what it is, and they show the building inspector, their certificate that they certify that this was the leakage rate for that. If they didn't pass, which is pretty rare actually, but if they didn't, then they show that they also did some extra steps to try to find the leaks and seal them up. But we haven't asked for another test.
That's great. I just want to say something that's a little irreverent. One of the reasons, in my opinion, that as a society, as a culture, we're so okay to test air leakage is because, and you mentioned the curtain wall thing, and I'd already written this note, but the curtain wall, it's like, it is the last remaining low-hanging fruit, except for the all-glass enclosure, which is still okay. And, Seattle has actually, compared to really cold climates, relatively moderate climate. But you have a long, relatively cool period, right? So you have a lot of heating degree days. I just wonder if the culture could shift on glazing, window-to-wall ratio.
The only building types that want to have and demand to have large areas of glass are high-rise office and high-rise residential. Everybody else is just fine with 30% or so of their building, their wall area.
So what's up with that?
It's real expensive real estate, and they want that wow factor, and they want the extra glazing. This is not the end of the world. There's all kinds of ways that energy is used or saved in buildings, and I would like to not see any more 60 or 70% glazed buildings, which I've seen down here in Texas, where you got real weather, winter and summer, and it's kind of crazy. But
it is.
But 40%, 45% glazing, we're finding ways to deal with it. Also remember that with the air barrier testing requirement in place for all buildings all the time, and with our stringent requirements for insulation and for quality of glazing and all that, the balance point for heating is pretty low. You have to get pretty cool out there, and in the afternoon after a building's been occupied all day, it could, I don't know, it might get down close to freezing before you have to
Really? I was wondering.
Heating on. Got a really good building enclosure, got a lot of occupancy and computers going and stuff like that. It's not so bad. Early in the morning, when people are first coming in and they're just getting started, you're going to need a fair amount of heat to get that going.
One thing that came up early on for me, so I'm a physicist and an engineer, and years ago I worked in a wind tunnel. And air is mass. Air is very heavy. So when you say CFM, you're talking about a mass flow rate, and you're not talking about a low number of pounds of air. You're talking a big commercial building could have millions of pounds of air in it, tens of thousands of which are leaking across the enclosure. So if you imagine 10,000, or let's say 60,000 pounds of air at the outdoor temperature made it into your building, well, of course. And I like to say that because people think, air, it's fluffy and it's this little thing and it's a little bit cool. If you say, let's say 50,000 pounds of air at 45 degrees entered your building unbidden, well, people can go, and which is not inaccurate, right? It could be that much or more. then it's like it's in your gut. It's like, 50,000 pounds of a cold fluid entered my building and I need to heat it up. It's a lot of computer monitors, it's a lot of human beings.
Well, with older buildings, there are often temperature complaints around the perimeter of the building. An old single-glazed building with leaky walls and like that. That was often brutal, and so older buildings always had heating sources, baseboard below the windows to try to counteract the draft that was coming down and balance it out. But that is really, you have to start moving that out of your mind for new buildings because those, we require thermally broken frames and these very highly insulated walls and slabs and stuff. So people right up against the wall are usually quite comfortable in one of these new buildings.
Mm-hmm. I thought it was great that you brought up highly glazed buildings because on the ride over here, Duane and I were actually talking just about that issue and what a challenge it is. And I have not just one or two, but several. Almost, I would say, Duane was worried about, not buildings that are 60 to 70% window to wall ratio, but trying to bring it down to 40 to 50. I have several buildings I'm consulting on that are above 90% window to wall ratio here in Austin, Texas. And it's a major, like you said, it has to be a cultural change among our fellow architects about understanding the glare that comes in it, the heat gain, the lack of interior quality space. Yeah. And then the other thing Duane and I were chatting about earlier was that when these architects are forced to scale back that window to wall ratio, and those successes are few and far between, but when they are, and it usually comes not from us, but from a code requirement. It simply will not pass code.
We'll talk about that.
That they usually do a great job of it. That they scale back the window to wall ratio, include really nicely designed shading devices or spandrel panels or whatnot. Sorry, not spandrel panels, but opaque wall assembly pieces that. In my mind, it seems like the design is dramatically improved.
Oh yeah, the building on Roosevelt Island that's passive house multifamily, it's beautiful, right? It's got low, like 40%.
The any of us who have been through design school know the fascination with this sort of pristine view of floor to ceiling, wall to wall glass, with everything all perfectly flat and skinny and even all around the entire building enclosure.
Like an Apple store.
This sort of glass purity, which we all learn to sort of honor. But that has, I think, the earliest renderings of those all glass buildings are from an entire 100 years ago, right? They would be like 1920.
Wow.
Was when that first started to appear in an architect's imagination, and I can't help but think that the day is coming, perhaps soon, when the fad finally dies after a century, and the next round of architecture students are going, what a boring building. It's just like glass, all over, and and it's really kind of uncomfortable. Awesome. You don't have any privacy. It gets cold to the wall. It's like
the shag carpeting or something like glass buildings are like shag carpeting.
Yeah, so it might be that there's this whole round of high fashion, highly glazed buildings that just looks really dowdy and old soon.
Well, I look forward to that day.
or the whole idea of passive survivability, right? And I was just thinking about the numbers. Keith has the numbers here written down: 0.4, 0.25, 0.15, 0.08. And in that mask metaphor, by the way, if we were just to start with 0.4 and go to 0.08, it would be tremendous difference in the terms of...
Now remember, though, that Keith has the thing pressurized at 75 Pascal, which is nothing to sneeze at. That's like some serious pressure.
Yeah.
On a non-windy day, it's
it's much lower.
5% of that or something like that.
It's a good point.
In the real world.
So I know RDH Labs is up in the Northwest. They have an office in Seattle. And I know they've been working up there for a number of years, at least as a resource for information flow. Mm-hmm. I mean, really, society is, you could consider human society as an information flow structure from natural sources of energy through our society to our end users.
Right.
And so one of these sources of flow is information flow, right? Like you mentioned, the problem is not the materials, the problem is the workmanship. Just down the street here, there's a residential structure. They used Huber zip system, and they're putting in their windows, and the bright, shiny, raw OSB in the corner of the window is very visible, and they've used the flashing, and it's in, and I'm walking my dog kind of like, well, they'll definitely fix that. Next morning, they're stuccoing it. I actually got some pictures, and I'm just incredulous, like running around like, I have to tell someone, like, all the windows in this house are gonna leak, they're gonna rot. Anyway, it's an example of the right materials. There was a person standing there with a razor knife, right? They just didn't have the right workmanship. And so information flow is very important. Do you think that RDH or other groups or someone like yourself, an individual, can have an impact over time? Tell me about that. You don't have to say yes. You can say, not really.
Well, RDH actually is one. There are not only them, but there's two other tremendous
enclosure firm.
building science firms in town, and maybe I would even include a third in that list of as far as information flow, it depends on not only on who's trying to say something, but on how receptive the hearer is.
That's a really good point.
I do a lot of speaking to various stakeholder groups, and I like meeting them on their own turf, at their own regular meeting time, as an invited guest. That sort of opens it up better than me just marching in and trying to tell people stuff.
That's so good.
Nobody wants somebody like me telling them how to do their business, for sure. and if I'm seen as credible and not just trying to push one viewpoint, if I'm and especially if I'm open to some circularity where somebody can stand up there and tell me why this rule that I just came up with is not going to work or is causing problems or something like that, then we can have an information flow. I don't think there's just such a thing as a one-way information flow. I think
you're right.
You're going to get that circular to and fro, and if you're credible and if you're honest and you're not trying to BS anybody, then that will get out there, and it'll take some time. But if you got somebody convinced that what you're talking about is worthwhile, then they can become your ambassador going forward to reach somebody that would never talk to you.
Do you code people share notes? Because I know Michael Husted and John Umferson, our neighbor in our city here, are in positions to make decisions like you've made, and I'm more the voice like, oh, come on, let's drag ourselves forward here, please. And instead, they're making relationships, they're listening, they're taking give and take, and I actually have great respect for that. I'm a little frustrated it takes so long, but is it a known practice to negotiate and barter and take time to build relationship?
We have.
Do you code people? Quote, air quotes.
No, we
talk about that.
It happens in the margins of the official processes.
Interesting.
And so, our state code development process, which we're right in the thick of right now. 2 days from now, I'll be chairing another meeting of that.
Wow.
It is
chair.
Quite formalized. I'm the chair of the technical advisory group, which then comes up with a list of recommendations that goes to the full State Building Code Council for their consideration. But it's a formalized process. We have Robert's Rules of Order. We have deadlines and formats and all that. In the midst of that, we start to talk, and we have experts around the table who can catch me if I'm about to go down some path that's going to mess everybody up. And so this job description increases your level of modesty a lot, because without all these other people chiming in their expertise, we've got a commissioning expert, Teresa's great. We've got a lighting expert, a couple of HVAC experts, and each of these different sort of viewpoints impinges on the decisions we make, and it's better. And then just in the we stop, we have a break for sandwiches at a certain point and say, okay, we got to somehow come to a resolution on this thing, and people start putting ideas up on the wall, and we, by that sort of informal processes that are happening around the perimeter of the formal process, it gets better. And a similar thing happens with the city. We have public meetings, and and we announce, we're going to be talking about commissioning this time, and all the commissioning people show up, and they'll let me know. They're not shy at all if I'm going down the wrong way. But even I found over and over the opposition, even people who are just dead set against energy codes altogether, they will find flaws with what we're doing, but it's really welcome, because then we find a way to fix the flaw before it goes out into the real world and starts causing a problem.
Well
as
said.
far as whether we communicate with each other, from city to city, it's really hard, because we all have limited travel budgets because we work for cities, and so we meet each other at these conferences once in a while, and there's a lot of email exchange. Right. I heard a rumor that you're doing something on air barrier testing. Can you send me that? And so there's an informal exchange, but it would we'd all benefit from having more of a structure to not have to go through the same learning curve independently for every issue.
Mm-hmm. I agree. So I have a question here. I have several. So I want to talk about the code that is currently there that you say actually is going to... right now you have a guideline or a threshold of this 0.4 ACH at 75 pascals, is that right? But you don't have to pass that. So I have two questions. I'll start with the first, and I can remind you. So about the second one. The first one is, when did that idea to make a non-binding threshold be the approach for code first come up? And there's like a three-part question, but maybe you can get it. When did it first come up? How was it received? Like, did people go, yeah, that'll never work? Or, so when did it first come up? How was it received, if you remember? And how did you make it work? Who was the first one that said, no, we're gonna do this. We're at least gonna try this?
I think that, and you're asking me to remember some meeting, from hundreds of meetings several years back.
You can ad lib.
Yeah, but I think the way it happened was that the proposal to require an air leakage standard was out there, and then there was this parade of people, going, what are you going to red tag this thing and have us sitting there with a building that no one can occupy because we're missing the standard by a little bit, and it's not like we've caused a life safety problem or something like that. It's we're talking about a little miss, and I think it might have been my idea to say, well, what if we don't require that we pass it, and so if it wasn't my idea, I was somewhere in the room and it was somebody else's, and I'm just taking credit for it now. But
and then that idea, people said, yeah, maybe
that emerged, and I did bring it up once at a national code hearing, and it got laughed out of the room right immediately. We can't have a code requirement and then not require that you meet the code requirement.
Code suggestion.
But it's actually, as a transitional strategy, it's a really good one, because before that, nobody had any idea what the leakage rate was. In fact, if you want to do a baseline comparison, how does it change from the old way of doing things to the current way of doing things? How much progress did we make? It's very hard to do because nobody's buildings are tested, and they're not going to empty out the building for several hours and test, and so you don't really know what to compare with. So now everybody knows how well their buildings are doing, and they've learned techniques for getting it down under the wire, and so the confidence is there that I think when I propose this next year that it will be well received, or maybe it won't be. There's still actually, when you think about it, the question: okay, what if you require it now and it still doesn't pass? There was one tall building that I won't name, but it was very heavily architected, all kinds of crazy angles and projections from this building, and they tried and they weren't able to make it pass, even though it was a curtain wall building, just because of it was architecturally unusual. So you have a situation like that. I had this idea that you could set up a schedule of penalties payable in solar panels. It sounds kind of silly, but you'd say, okay, we're missing the standard by 5%, and somebody do a calculation and say, well, that would be so much energy that you've lost in the course of a year, and therefore that's a 5 solar panel penalty, because you missed by this chunk. Something so that you wouldn't. The bank would never lend if they knew that there was a chance that they could have this whole investment for $80 million or whatever and not have it occupied.
That's a good point.
But if you give them some way to deal with it and just make sure that it's always easier and less painful to pass than to do whatever the penalty is. You want people to avoid the penalty thing. Still, the other side of that is that, okay, it's another way that energy use is decreased, and so there's a certain equivalence there.
Yeah.
Duane, I missed one thing. You said you're proposing a change in the coming year. What is that change?
Well, that would be to go from you don't have to pass to you got to pass.
And not only that, it has to be 0.3, not 0.4.
It's already 0.3.
Oh, it's
Okay.
0.3, not 0.4. Excuse me.
So, the state code level is still at 0.4, and our current Seattle code is at 0.3.
Okay.
And it really, since everybody had plenty of notice and they were already pretty much there anyway, it hasn't been a problem.
Okay. Well, maybe the second part of my question isn't that important, and I'm tempted to go a different direction, but the second part was going to be, you said, if you don't pass, you get to choose from a list of a few other things. I think you said there was 8.
Oh no!
What happens if you don't pass?
This was not to do with passing or not passing. This is
okay.
the 2 above code options that you have to pick from our list of 8 options, and so you can do more efficient lighting, mechanical systems, water heating, solar on the roof.
I get it.
There are a number
so
of
it had
things.
nothing to do with not passing the air.
And one of those is to hit a tighter air barrier standard.
Okay, good. Well, good. So, you mentioned that this just came up, the challenge of comparing new versus old. It seems that you could take a building of similar size and just compare energy use and calculate EUI out of building from the 80s versus a...
Well, that would not be fair because you'd really need to compare it with a building that was somehow built in the same market without this requirement. But you could say compare it with say a Portland building or a Boise building, perhaps. It would be a similar enough market and climate zone and like that to be able to say, well, we're how it compares. But there's some testing that's out there on existing buildings. I've seen a list of them, and also most people beat the test standard by quite a bit.
Wow.
And because they don't want to be over that line, and so they and it turns out that it's really, as the Passive House people will tell you, it's just not that big of a deal.
Yeah. Okay. Well, that's good.
It's a big deal when you have to change the way you build things from the beginning.
One of the things about energy code that I don't think people realize, which is very important, is that it's basically a societal agreement among people. And it's society agreeing with itself to set targets, to kind of plan the way it evolves and what's important to us. And we as a culture have said, energy and material resource conservation is important. And that's what's happening here, is you're saying, okay, well, and then how do we make that happen?
Well, not only that, it is critical that it be a mandatory requirement. All the above code programs out there that get all the publicity and they're so lovely aren't really moving the construction industry at all. What moves the construction industry is when you don't have any choice. If you want a building permit, this is how you have to do it. Then the miracle of capitalism kicks in and people start figuring out smarter, more cost-effective ways to do things, and it rapidly becomes the new normal. Whereas if you want to do a LEED platinum building or something like that, it's all one-off special order, high-risk stuff. Mm-hmm. And so making it normal, it's going to be a difficult learning curve every time. It's painful for the whole bunch. There's a lot understandably lots of complaining, and then it becomes just the way we do things. And that's what is important about things being a regulatory system rather than just a voluntary feel-good thing.
Wow, man. So that, unfortunately, we're trying to wrap up. You just let the cat out of the bag, Duane. I mean, that's the bombs. In the sense that, look, so Living Building Challenge comes up, like LBC. In some sense, you could say Living Building Challenge absolutely changes the paradigm. If you say, look, this is possible, right? What was your quote? It was,
that which exists must be possible. And in Seattle, we can point up the hill at the Bullitt Center and say where living building people are, and then say, sure, they did it. And
so you're saying it's a both and it sounded like you were saying LBC doesn't matter, it's just code that matters.
It's the great thing about Living Building Challenge, about some of the lead things and others, Passive House, is that as markers out in the sand further along, they show that this is possible, and they start to develop techniques to do these things at a small scale. But that impacts maybe, if you take all those programs together, maybe 3% or something of the total commercial construction
and the
market.
energy impact is fractional, you're saying.
Tiny. But
turns the super tanker.
It could be that that's where we look for the next idea to move up that floor, which says, no, this is what you got to do.
Yeah. We've often internally here, Miguel and I have called Passive House and Living Building like lighthouses or beacons in the dark, and you need to know which way to move.
I'm sure they'd love hearing that. Yes.
And so where I thought we were going to go, I want to ask both of you. This one is since I live in Austin, and it's hot and humid here, and well, actually, not since it's hot and humid. Since I live in Austin, I care about this. Oh, I'm interrupting my own thought. So human caring was at the point of this. This idea that here you are on this board and you're going to be the chair of the technical advisory group. You know, it's a professional role, but underneath it there's this human that you are, and you care about your world and you care about your job. And then there's a GC who cares, and a subcontractor who cares, and a developer who cares. And so I think I don't want to lose sight as, technicians and technical people that there's this soft side of it too, that you just care about what you do,
We all are really proud of the work we do. Yeah. Everybody that you just mentioned, that whole extended team is really into this. Yeah. And how cool is it that I get to go to work every day on arguably the most critical issue facing our time.
Yep.
And get to be right in the middle of the scrum.
That's so cool. Well said. So how can Austin follow your lead? What can we do here in Austin, either one of you?
So I would say testing is so important. I mean, it doesn't, not just air leakage testing, right? You do mechanical testing and duct testing, and we do water testing of fenestration, all kinds of testing. We learn so much from testing. And so we have to do more testing. I mean, we're already doing it, requiring it for residential, but we need to require it for commercial. And there was it was in the code, and then it came out of the code, and people said, well, what are we going to do if it doesn't passes and we can't figure out the ramifications? And I almost want to slap myself and say the answer was right in front of us. Seattle figured it out. You don't need a ramification. It's so crazy, but it's perfect.
Just get the data and let people know where they are.
Personally, I've never learned so much about buildings as when we've done whole building air leakage testing. Just walking around and listening for the air infiltration and feeling it, and that translates into better detailing and better knowledge. I mean, it is truly tremendous.
Require the developer be there.
Yes.
Feel it too.
Yeah, so just tell them how exciting it is. It'd be a hard sell.
The critical thing is that nobody in Texas wants to hear how they do it in Seattle. You're going to get booted out of the room with one of those cowboy boots they have down here. And so you're going to have to understand, what their values and their worries are, and respond to that and respect it and be there with them. And it's only at the point where you become people's respected expert or advisor that you're going to be able to break through, because otherwise the force will always be in the direction of leave us alone, we know how to do things, we want to be left to do things the way we like it the best. Yeah. And so if you're going to be pushing change, you have to understand it from their viewpoint, and you have to make your viewpoint be an attractive thing that they want to come to.
Uh-huh.
It's a good trick, but like you said, we're talking technology, but we're really in human nature.
Yeah, we're in the heart. I think that's a great place to end. I can tell you from my heart, I've really personally enjoyed getting to know you and talking to you and sharing ideas. And thank you for being here.
Thank you for having me, Kristof.
Thank you.
Thank you.
And Miguel.
And thank you all for listening.
See you next time.
Bye-bye.